What if you could figure out how a pendulum swing depends on its length without knowing any physics, without solving a single equation, just by paying attention to units? The same trick reveals the smallest meaningful lengths in the universe. Tracking units is secretly a discovery tool. To see how this magic works, we first need one simple rule. Every physical quantity carries dimensions, and every honest equation must respect them. From that single constraint, we'll deduce the form of real physical laws. Then we'll feed in the deepest constants of nature and construct fundamental scales of the universe out of pure numbers and units. Start with dimensions. Every physical quantity is built from three basic dimensions: length, written L, mass, written m, and time, written t. Dimensions aren't the same as units. Meters, feet, and miles are different units, but they all measure the same dimension, length. Kilograms, grams, and pounds all measure mass. Seconds and hours both measure time. Changing your units never changes the dimension. This distinction matters. Dimensions describe the kind of quantity, while units are just the human-chosen scale we measure it in. Here's the one rule that powers everything. Both sides of any physical equation must share identical dimensions. You can't equate seconds to meters or mass to time. This sounds obvious, almost trivial, but it's a genuine constraint, strong enough to reveal the shape of physical laws all the way up to one unknown dimensionless number. Let's prove that with a swinging pendulum. What sets a pendulum's period? Let's list the quantities that might matter. First, the length, capital L, with dimension length. Next, the mass, m, with dimension mass. Then gravity, g, the acceleration, with dimensions of length over time squared. And finally, the swing amplitude, theta naught, which is an angle, a pure number with no dimensions. Now watch the mass. Its dimension, mass, appears in m and nowhere else. No other quantity carries mass to cancel it. If mass appeared in our formula, nothing could balance its dimension. So mass cannot appear at all. The period of a pendulum is completely independent of how heavy the bob is, and we discovered that without doing any physics. With mass gone, only length and gravity remain to set the period. Look at the ratio L over G. That's a length divided by a length over time squared. The lengths cancel, leaving just time squared. So the square root of L over G has the dimension of time, exactly what a period needs. Therefore, the period t is proportional to the square root of L over G. The proportional symbol means equal up to a dimensionless factor. And that's the catch. Dimensional analysis gives the form, but not that leading number. The true factor here is 2 pi. For a 1 meter pendulum with g of 9.8, that gives 2.0 seconds, matching reality. If units can tame a humble pendulum, what happens when we feed them the deepest constants of nature? Take 3. The speed of light c, from relativity with dimensions length over time. The reduced Planck constant h bar from quantum mechanics, with dimensions mass times length squared over time. And Newton's gravitational constant g, with dimensions length cubed over mass over time squared. Now ask one question. Can we combine these into a length? Write the length as c to the power a1 times h bar to the power a2 times g to the power a3, and demand that the total dimensions equal pure length, then match each dimension separately. For mass, we get a2 minus a3 equals 0. For time, we get minus a1 minus a2 minus 2a3 equals 0. And for length, we get a1 plus 2a2 plus 3a3 equals 1. Solving that system is quick. From the mass equation, a2 equals a3. Feed that into the time equation and you get a1 equals minus 3 times a2. Then the length equation, a1 plus 2, a2 plus 3, a3 equals 1, becomes 2a2 equals 1. So a2 and a3 both equal 1/2, while a1 equals minus 3/2. That means the only length you can build is the square root of g times h bar divided by c cubed. This is the Planck length. Now plug in the numbers. G is about 6.67 times 10 to the minus 11. H bar is about 1.06 times 10 to the minus 34. And c cubed is about 2.7 times 10 to the 25. Multiply g by h bar, divide by c cubed, and take the square root. The result is roughly 1.6 times 10 to the minus 35 meters. That is absurdly small, a billion times tinier than a proton. On a logarithmic scale of size, the Planck length sits at the very far left, far below the proton, the atom, a human being, and the observable universe. Now flip the question. Instead of building a length, let's build a pure number, a quantity with no dimensions at all. We'll use 4 constants: the elementary charge E, the vacuum permittivity epsilon naught, the speed of light c, and Planck's constant h. It turns out there's exactly one dimensionless combination you can make, and it's E squared divided by 2 times epsilon naught times c times h. When you track the units, every single one cancels perfectly, leaving a bare number behind. Now plug in the values. E is about 1.602 times 10 to the minus 19. Epsilon naught is about 8.85 times 10 to the minus 12. C is 3 times 10 to the 8th, and H is about 6.63 times 10 to the minus 34. Working it through, the numerator E squared is about 2.57 times 10 to the minus 38, and the denominator is about 3.52 times 10 to the minus 36. Dividing gives about 0.0073, which is very close to 1 over 137. This is the fine structure constant, alpha, the strength of electromagnetism. Why does alpha matter so much? Because it's dimensionless. A length of 1.6 times 10 to the minus 35 meters becomes a different number in feet or miles. But 1 over 137 is 1 over 137 in SI units, in CGS units, in any natural units, for any alien civilization. It depends on nothing humans chose. It's a genuine fingerprint of nature. These aren't mathematical curiosities. 137 is hiding inside every atom you're made of. The energy that binds hydrogen's electron, the Rydberg energy, equals 1/2 times the electron mass times c squared times alpha squared. Take the electron's rest energy, 511,000 electron volts, multiplied by 1/2, then by alpha squared, which is about 5.33 times 10 to the minus 5, you get 13.6 electron volts, the exact ionization energy of hydrogen. The fine structure constant literally sizes the atom. Dimensional analysis is the physicist's first guess. Before any hard calculation, it tells you what could be true and what's impossible. And the fact that numbers like 137 exist with no known reason why remains one of physics' deepest open mysteries.